So far your automation runs when you run it. Now we cut the cord. Azure Automation hosts your PowerShell as runbooks that run unattended in the cloud, on a schedule, authenticating with a managed identity so there are no secrets to leak. This is how real endpoint operations run nightly reports and off-hour sweeps without anyone staying late. A script that only works when you run it on your laptop is not really automation, it is a chore with extra steps. Azure Automation hosts your PowerShell as runbooks that run unattended on Azure's own compute, on a schedule or a trigger, with no machine to leave switched on and nobody to remember to click run. Reach for runbooks for anything recurring at fleet scale, nightly stale device reports, scheduled group hygiene, off-hours remediation sweeps. The worst thing you can do is paste a username and password into a script. A managed identity solves this completely. It is a credential that Azure attaches to your automation account, rotates automatically, and never reveals to you. The Graph SDK connects to it with a single switch, connect-mg graph-identity. No secret, no prompt, nothing to leak. This one practice removes an entire category of security incidents, so make it your default for anything unattended. Because a runbook runs as itself, with no human signed in, it cannot use delegated permissions, which act on behalf of a signed-in user. Instead, it uses application permissions, also called app roles, that an administrator consents to once. The principle of least privilege still applies just as hard. Grant the identity only the specific app roles the runbook actually needs, nothing more. Knowing the difference between delegated and application permissions saves a lot of confusing 403s. Granting the permission can itself be scripted. You find the Microsoft Graph Service principle, that well-known app ID starting with 0003, and your managed identities service principle. Then you pick the exact app role you want by its value, like device management managed devices.read.all, and assign it with new-mg service principal app role assignment. An admin runs this once. Now your runbook's identity can read managed devices and nothing else. A runbook can only use modules that have been imported into the automation account. Import the graph sub-modules you need, and crucially, pin their versions. Why pin? Because an unattended job that always grabs latest can break silently at 2 in the morning when a new module version changes behavior. Pinning gives reproducible runs. It requires lines at the top of your runbook declare exactly which module versions it expects, documenting the contract right in the code. You attach a schedule to a runbook, daily, weekly, or a recurring interval, and you can pass parameters at runtime. That means one runbook serves many cases. The same stale device report can run with 30 days for one schedule and 90 for another, just by passing a different stale days parameter. A well-parameterized runbook is reusable infrastructure rather than a one-off. Define your perms at the top, just like any advanced function. Because there is no console watching an unattended run, the job log is your only window into what happened. Azure captures every write-output, write-error, write-warning, and write-verbose per job in the job history. So design for that log. Write a clear summary of what the run found and did, and let real failures surface as errors. Then review the per-job streams in the automation account to confirm success, and wire an alert on failed jobs so a broken schedule does not go unnoticed. Let us recap. Azure Automation runs your PowerShell as runbooks, unattended in the cloud on a schedule. Authenticate with a managed identity using connect-mg graph-identity. So there are no secrets. Because there is no signed-in user, you use application permissions, granted least privilege. Pin your module versions for reproducibility, and design every runbook for its job log. Your task: design a runbook called report-stale devices that connects with -identity, takes a stale days parameter, lists devices stale beyond that window, and writes a JSON summary. State the exact app permission its identity needs and why, pin the graph module versions with requires, attach a daily schedule, and describe how you would read the log and alert on failure. See you in the lab, Lesson 8.